In this video, we're going to talk about volume versus temperature. So we're under this tab right here. And the very first thing I want us to do is talk about what volume is, what temperature is, and what relationship we're working with here. So let's remind ourselves that volume is the amount of space something takes up. And temperature is our speed of our particles. So space and speed here. We know that our graph looked something like that. So when one variable went up, the other variable went up. Or when one variable went down, the other variable went down. And we call that direct relationship. Okay. So they're moving in the same direction. Let's go ahead and look at these questions. So I'm on the left side. And our first question says, if I have a balloon at 45 liters, so 45 liters, that's probably important, I'm going to underline it, of helium in a balloon to 98 K, and increase the temperature of the balloon to 328 K, what will the new volume of the balloon be? So I know I'm working with volume and temperature, so I'm going to go ahead and write my variables down. 45 liters to 98 Kelvin. We don't know our new volume, so we're going to put X, and 328 Kelvin. So now I'm ready to put it in a table. So I have volume and temperature here. I'm going to put my couple that's already together, that already has both numbers. So we need couple 1 here. So I've got 45 liters and 298 Kelvin. Don't know my new volume, and I got 328 Kelvin. So I'm going to look at my one that has both numbers again. So here I'm looking at temperature. So from 298 to 328, my temperature increases. And we just said that these move in the same direction, so when temperature increases, volume increases. Then we're ready to set up our math problem. So I'm going to have 45 times. My arrow with my X is pointing up. That means my larger number needs to go on top of the fraction. We need that fraction to be greater than 1. Let's go ahead and put that in our calculator. We get 49.530200134. Now we don't want all of those numbers, so we need a sig fig here. So we have 1, 2 sig figs there, 1, 2, 3 sig figs there, 1, 2, 3 sig figs there. So I can only have 2 in my answer. So 1, 2, and I say, what does that 5 do to that 9? Well, that rounds it up. So I either need 50 point, no 0, but you got to keep that decimal in so that my 0 is, my current 0 is significant, or we could put that in scientific notation. And either way, my unit is going to be in liters because this unit is in liters. Okay. Let's look at our second one here. It says I have 130 liters of a gas, so 130 liters, I'm going to underline that, in a piston at a temperature of 250 degrees Celsius. Now, just like in pressure versus temperature, we have to change that Celsius to Kelvin, so we need to remember to do that when we pull out our variables. If I cool the gas until the volume decreases to 85 liters, what will the new temperature be? So I'm working with volume and temperature again. So I'm going to go ahead and write my variables down. 130 liters, liters is volume. 250 degrees Celsius, so I need to add 273 here. And that gets us 523 Kelvin. But notice this 0 is not significant, so I cannot have this last number here, this ones place. So that 3 does what to that 2? Leaves it alone. So we actually have 520 Kelvin. Then my new volume is 85 liters. And then I don't know my new temperature. So I'm going to go ahead and put this in a table. Volume, temperature. 130 liters, 520 Kelvin, 85 liters, and X for our temperature there. Our volume decreased, so if our volume decreases, our temperature decreases. Then I'm ready to set up my math problem here. So I'm going to come over here for more space. My arrow is pointing down, so my larger number is going to go on the bottom. Put that in our calculator. We end up with 340. When we talk about sig figs, we have 2 here, 2 here, 2 here. We can have 2 in our answer, which we already do. So I just need my unit here, which is in Kelvin. So it just said what will the temperature be. It didn't tell me a specific unit, so I can leave that in Kelvin. If you change it to Celsius, that's fine too. I usually don't unless the problem asks me to. Those are our first 2 questions. Let's look at our next 2. So now I'm on the right side of the foldable. So here, calcium carbonate decomposes at 1200.0 degrees Celsius to form carbon dioxide and calcium oxide. If 25 liters of carbon dioxide are collected at 1200.0 degrees Celsius, what will the new volume of the gas be at STP? Now it gave us this number twice. We only need it once, so this is just background information this first time, and the second time we're actually getting information for our problem. Now you notice I also underlined STP. Remember, STP is standard temperature and pressure, so this is where we're getting that information for our temperature. So let's go ahead and put our variables down here. So we have V1, T1, V2, T2. So my initial velocity here is going to be 25 liters and 1200.0 degrees Celsius. Now I need to change that. So we'll get 1473.0. Now there's no decimal place here with my 273, so I cannot have this 0. So I'm going to end up with 1473 K. Now we can keep that 3 this time because that 0 is significant. So that's when you're going to have to go back and look at when zeros are significant and when they are not. So be conscientious about that. Now we want to know what the new volume will be, so I'm going to put an X there. Then we talk about standard temperature. So we said that standard temperature is 0 Celsius or 273 Kelvin. Well, we want our temperature to be in Kelvin, so I'm going to go ahead and use Kelvin. So 273 K. And I'm ready to set up our table. So we've got volume, got temperature. Going to use the couple that's already together, so here that's couple 1. So 25 liters, 1473 K. Don't know my volume, and we're getting to 273 Kelvin. So my temperature decreased. So when temperature decreases, volume decreases. So that's the arrow we're going to focus on. So 25 times, we're looking at our fraction. My arrow points down, so my larger number is going to go on the bottom here. Put that in our calculator. And we get 4.633412. Now let's talk sig figs here. Have 2, 1, 2, 3, 4, 1, 2, 3. So I can only have 2 in my answer, so 1, 2. I say, what does that 3 do to that 6? Nothing. So 4.6. Now I'm looking for my unit. Looking at volume, my initial volume was in liters. So my answer is going to be in liters. Okay, let's check out this last problem. This is one of those where the wording is what throws people off a lot. So we need to be conscientious of that. So this is Jennifer's large pool float was sitting outside on a hot summer day. Based on the packaging, the pool float has a volume of 25 liters. When Jennifer initially filled up the float, it required 24 liters of air when at 19 degrees Celsius. So 24 liters when the air was 19 degrees Celsius. What temperature is the float when it's outside in the sun? So let's look at this. So V1, T1, V2, T2. So initially it tells us that we're at 25 liters, but it doesn't give us any temperature, so we're going to skip that part for right now. Then it goes on to tell us that we have 24 liters at 19 degrees Celsius, and it wants to know what temperature it's going to be when it's out in the sun, so we're going to put an X right there. Now we need to go ahead and change our temperature to Kelvin. So 19 plus 273 gets me 292. And since both of these in the ones place are significant, I can keep that whole number. So now I'm ready to put it into the table here. I'm using the couple that's already together, so this time I'm going to be using couple 2 in my table first. So 24 liters, 292, 25 liters, and X. So my volume increased. When volume increases, temperature increases. I'm always looking at my arrow with the X. Now we're ready to set up our problem. So 292 times, looking at my fraction here, my bigger number is going to go on top of my fraction. So 25 divided by 24, so let's put that in our calculator. So I end up with 304.1667. Now let's talk about sig figs here. I have 2, 2, 3. So I can only have 2 in my answer, so I have 1, 2. So what does that 4 do to that 0? Nothing. Now I cannot write just a 30 here, and there's no way for me to just use a decimal. So this is going to have to be in scientific notation. So 3.0 times 10, and we had to move our decimal 1, 2 places. And our unit here is in Kelvin. And that's our final answer. Now again, you can always change that to Celsius if the question asks for it, but none of these did, so we did not have to change it. If you're changing something to Celsius, you're just subtracting that 273.